Some of you who have known me a few years may know I have been working on a PhD in systems engineering through Colorado State University. I'm happy to say I successfully defended my dissertation 2 weeks ago. So I am done, and I'm pretty pleased to have this accomplishment. And I thought as part of this month's presentation, I'm going to go ahead and share with you the material that I put together as part of the defense. And it's a lot more than the time allotted, so some of it I will skim through. And some of it's actually going to be part of my IS 2021 presentation. I did get a paper accepted. It is a distilled version of my dissertation topic, focusing primarily on the system model I made for the requirements management process. And that I will go ahead and present this summer. So today I'm going to focus mainly on the research, the processes and information I've uncovered, and the recommendations I've made, and some of the highlights of the modeling I did to kind of inform whether those recommendations made sense. So without further ado, I'm going to go ahead and get started. The topic of my dissertation was cost optimization in requirements management for space systems. And for those of you who are less familiar with my work, I've been working in the aerospace industry for about 30 years. Primarily on spacecraft, but I have worked on spacecraft products, things that go on spacecraft. I've done design work, test work, systems engineering work, and I have been a requirements manager for a couple of space projects. So through that experience, I think I and many others who join Requirement Working Group have had a lot of opportunity to see that there's a lot of room for improvement. Let's just say that. Room for improvement in how we do business in the space industry for managing requirements. So I'm going to hit on some of those as part of today's talk. So this is a theme of what I'm going to go through. I'm going to define the problem statement, let you know about the research, hit into the overall process model and some of the improvements I'd be recommending. Honestly, while I'm focusing on the space industry, let me say that that's because that's my experience and what I chose to research. I think a lot of what I'm presenting here today is appropriate for any complex system. There is certainly a lot to be said for aviation and potentially automotive, anything where you have a lot of hardware software interactions, anything where you have a lot of rapid change in technology. Certainly space systems is one of those kinds of applications. And for just an example of what a space system would look like, we've got the GOES-R spacecraft represented here. All of the space projects I'm presenting, I did not personally work on. They are NASA projects. And what I really like about NASA projects is it's pretty open to the public, a lot of the information about these projects. You can get a lot of information around their approaches. You can get their specs. You can get their requirement management plans and their spec trees. And you can even get a lot of data from the Government Accountability Office, GAO office, about how each of these projects has performed. And that's a key is, were they successful in various measures that I'll talk to shortly. So NASA projects is really what I'll highlight here, but I will say they're highly reflective of many of the projects that I have personally worked on in my career. And by the way, thank you for the nice comments in the chat. I really appreciate that. Okay, so really the key is complex system like a space project can have tens of thousands of requirements across multiple levels of development. And if you don't manage them well, these can actually drive cost in a few different ways. And I'll highlight a few in another slide. But the investigation focus was to look at, are there processes that can be applied to ensure a requirements-driven effort is implemented, which meets the objective of the product's needs, the constraints of the developer's budget and schedule, and ensure it's tailorable so that you can have an optimal approach for the product you're developing. Now, when you think about project success, one of the things a lot of us talk about is the triangle, which is technical, cost, and budget. But I'm going to bring in a little fourth perspective, which is called client acceptance. That's this idea here. And success is this happy meeting ground of all of these parameters. And when I talk then about cost optimization, I'm talking about the minimal cost when you still meet all of those other parameters. Now, the why I talk about customer acceptance is that starts hitting into a lot of themes we're doing in the Requirement Working Group around needs. And the customer needs are one of the most fundamental needs on a project. When you're starting to develop and thinking about system validation, a lot of times that's really ultimately what you're talking about is your client acceptance. It can work wonderfully, it can perform wonderfully, but if it doesn't have that system validation, it still won't necessarily be considered a successful project. So we are looking here for cost optimization to find the success with the lowest cost. Now, why would we want to optimize the requirements management process itself? When you think about all the processes on a project, why this one? And the key is it's kind of one of those hidden sources of cost. We have certainly realized there's lots of requirements and that requires a staff to manage them. The effort between transforming a set of needs to your requirements is iterative and can often take a lot of time, and people may not realize that you're doing this in waves or in cycles. There's not always one golden answer, you know, right off the front. And that work itself can be impactful if not done well, and not if the data is not managed well, if the understanding of changes between all that is not understood. There's another challenge, which is when you're working on a new development project, sometimes you want to put your suppliers on contract pretty early. And what the key is, you may not know everything you want them to do yet. So what you ask them to do pretty early can matter, and how you do it can matter, and that can drive a bunch of costs. You've probably, I'm sorry, did I have a question?
If you don't mind.
Okay. I'm going to mute background noise, and if you have a question, feel free to unmute or put it in the chat. Okay. So anyway, the key is there's an opportunity here for optimizing a process where there tends to be a lot of sources of cost associated with it. So I'm going to talk a little bit about some of the requirements engineering research I did. And this had to do with both the definition of requirements and needs and the management of it. So it's not just the requirements management piece of it I looked into. And so a lot of it is documented in quite a source of literature, ranging from textbooks to articles. And I've even done a series of interviews. So it just highlights that, again, many of you are the folks that know this just as well. When we talk about requirement, and the IEEE definition of this is, it's a statement which translates or expresses a need and its associated constraints and conditions in a very specific, precise, and unambiguous manner. And we wrote a whole guideline associated with how to do those things and what that should look like. And ultimately what you'll see is you've got the highest level needs and requirements, and then they usually get decomposed then through different levels of abstraction down to ultimate products that we'll design or procure or develop in some fashion. And then what you got then is a lot of data associated with all that requirements work. And so requirements management consists of the activities that identify, document, maintain, communicate, trace, track requirements throughout the life cycle of a system, product, or service. So it's managing all that data and making sure we understand it, making sure it goes to the right people and communicated in the right forms. And so what we want to do then is really get a firm understanding of what it takes to do that well. And there may be different processes depending on how complex your project is. These are some extractions in this particular bottom one. Some of the ways I can think about requirements management versus either the requirements definition or development process is through this picture from Pohl's textbook on requirement engineering processes. He's got requirements management dealing a lot with the change control, version control, tracing, impact of changes, and status, and understanding like maturity. And then we've got the definition process here, which is all about elicitation and analyzing and maybe modeling to some level to really figure out what those requirements are. And then ultimately making sure they're the right requirements and done well. So talked earlier, there's a lot of costs associated with poor requirements engineering, ton of articles on this. So I just highlight a few here. There's different types of failure having to do with industry surveys where people have indicated these things happened because our company did not have a robust requirements management process. You've got the infamous, I guess, studies done by NASA about the cost growth later in a project life cycle when you uncover an error due to poor requirements definition. And then you also have the aspect if you don't spend enough time up front determining what your right requirements are, your needs and your requirements. if you don't spend that proper time up front, you tend to see quite a large overrun. And this was just a sampling of many, many programs where they were really investigating how much time did they spend and what was their ultimate end cost. And so there was also a safety aspect. It's not always about the money. Sometimes it can be about the public safety. And in an aviation industry research, there was a thing that found on poorly defined requirements associated with software actually was correlated a lot with the, many of the accidents they were finding. And they were of a belief that those poor undefined requirements could potentially be a root cause for several of those accidents. So I looked at 9 different publications. I certainly have all of this written in the dissertation, so I won't go at great length about all of them, but I found some themes, and some of those themes found that there's a huge, huge amount of information about how to transform needs to requirements. And all the publications had some in-depth model or set of instructions or set of information on how to do this. Surprisingly, only 3 of those 9 publications really provided that same level of information associated with managing that requirement set. And I thought that was interesting, considering when you're dealing with management of requirements, it's where a lot of the work is in understanding how they relate to each other, how to manage that data, how to understand the change control, and not seeing a lot of practical guidance out there. I was pretty confused as to why the focus was all about developing requirements and not what to do with it once you had them. So I decided to look into that. That was one of the reasons I decided to really get into this research, was to see, is there anything we could put together? And that's what we're doing in the requirement working group. And it's what I did as part of the study to help address an understanding of this practice. And the key themes in this practice, again, are requirement traceability, change control, and completion status and stability. So through all those publications, I put together this process model. It's pretty high level. I put it in the form of a V, but what you're basically dealing with is the management process itself, not necessarily the development or definition process. I think that's very well understood and very well modeled. So I put this model together as a way to understand what are the various steps and how do they relate to each other. One thing you'll notice, I drew it in Visio. And when you draw something in Visio, it's pretty static and one-dimensional, or maybe two-dimensional. And one of the things I do later is I take this to another level by actually making a model out of this in a Sysml modeling tool, where you can then drill down to each of these steps and understand the related inner steps, and even drill down even deeper. And you can look at the interfaces a little bit more richly in that way. Okay, so after studying each of that research, modeling the major process, did a lot of interviews, did a lot of studies on current trends, and I ultimately came up with some proposed areas within those steps that might make sense to study further and see, could we do it better? What are the common ways it's done now? What are some better ways it could be done? And so that's where I get into researching requirements management challenges and finding some themes, finding a common set of themes through all the different research of recommendations of things we should do better. One of the things that I will advocate is project cost is a function of requirement quantity and quality, and that comes up quite a lot. You saw when we have poor requirements, obviously we do drive cost. There's actually a cost modeling tool for space systems called Sysml, I'll show here in a minute. And that's actually showing cost literally as a function of the number of system level requirements. It's an indicator of essentially where a project will fit in terms of manpower needed. There's also just a general, and this is not just requirements, but overall, a move away from a document-centric approach and towards a data-centric approach. And if any of you have seen the white paper, Integrated Data as a Foundation of Systems Engineering, you'll understand this theme. If you've not seen it, it's a requirement working group white paper written a couple of years ago, and you can get links on our pages, and I highly recommend you read it. But the concept here is there's a lot of project data out there, and getting this data intertwined really enriches the capability of a project to manage anything from their needs understanding, their requirements definition, their verification definition and planning, how we can relate that to our analysis results in our models, our system model. All of that can be data centric and connected together. So this view of our requirements as this document, this Word document, is kind of becoming an outdated model. And a lot more organizations are starting to utilize more of a data approach to the requirements instead of a specification driven approach. So I'm going to talk about that a little further, but that's really what this picture is visualizing. The third theme was really then kind of a companion piece to that, which is use of requirement management tools has been shown to greatly enable a project success. So if everyone's using Excel or Word, they, on a simple project, that might work quite well. But you get on a very complex project, all of a sudden you lose a bit of insight, and you definitely have an opportunity for errors. Careful planning on when to start change control. That's another theme that resonated frequently. Those suppliers that you need to put on contract, if you start change control and you have a ton of unknowns in your requirement set, all of a sudden they're working at risk, you're doing a bunch of changes, and we've got impact analysis and costs associated with that. So there's a sweet spot maybe of when you want to just mature everything, then lock it in, and now start your change control. So I took those 4 items, and then I also looked at a bunch of different space projects. As I mentioned with NASA, these are the 5 different ones I studied, just using information available to me. And I was able to find out things from how many requirements they have, to various parameters of success, and success is judged by the GAO office here. I would say there's a lot of reports written about these projects in terms of how well they did or did not do, and if they didn't do well, what didn't go well. There's also some internal reports or reports written by some of the NASA organizations. There was a paper from somebody who worked on the MSL project on the Curiosity rover on what they thought of their requirements and lessons learned. So I was able to pull through a lot of this data, and I was able to kind of trend at a high level the projects that seem to do well and kind of their complexity, and the projects that seem to really have challenges. Now, the only project on here that's not done yet is Artemis. Obviously, that's in work, but the other 4 are in some sort of completion status, and Constellation was canceled. INCOSE, Curiosity, and Maven are all launched and successfully doing their job from a technical perspective, but Curiosity and INCOSE had some challenges from a cost and general schedule perspective. And in fact, on INCOSE, they had to downgrade some of the technical they were going to do. So they actually reduced their technical capability to be able to fit into the parameter they needed to. So interesting study on all of these. What does that have to do with requirement management? I'm certainly not going to say requirement management is why these projects suffered. What I'm going to say is there seems to be this ripe opportunity for some of these projects that they could have been enabled or perhaps had a little better of an, I guess, performance if they would have had some optimization in the way they approach their requirement management. Okay, so I came up with 4 themes. Based on what I found in my themes of research, my 4 proposed process updates. Now, these fit into that earlier model I showed you in these areas that are green. In some capacity, this set of 4 things fit in those areas. And so there were certainly lots of part of the processes I could have looked at as well and maybe tried to refine them. But I chose to just scope it to these 4. Implement a data-focused requirements management approach. Use a management tool that supports electronic collaboration during the requirement development and change activities throughout a project lifecycle. Minimize and consolidate the requirements for the system of interest, and coordinate the timing between developing the requirements and levying them officially. Now, on number 3, it's interesting. You're like, minimize and consolidate. What does that mean? Well, ultimately, it means improve your requirement quantity and quality. Make sure you have not too many requirements, not too little, but find that sweet spot of what are the right amount of requirements, and make sure that the quality is appropriate. Don't have a lot of overlaps. Don't have poorly traceable requirements, hard to implement requirements. So that's really, when I say minimize and consolidate, that's ultimately going hand in hand with the requirement quantity and quality. And so my hypothesis is Any of those four would probably enable a project to succeed in some level with cost optimization in the execution of their requirement management. The thought is all four of them together would really work well. But when you're dealing with new processes and tools, you are dealing with some upfront costs. So cost optimization is really about what is that upfront cost you want to do with the return on investment you're going to get with any of these processes that you might be implementing. So you have to have some series of measures to understand your return on investment. Is it worth buying that tool? Is it worth training your staff? So I looked at different measures that we can consider on a project, and the cost of application and maintenance of any new process and tools would be your expenses. Your cost savings then would be perhaps something you can measure associated with labor savings. It will take your team less time to do something. Perhaps direct cost savings. You're not spending as much time with change orders with your suppliers. So down here, then you can see kind of the benefits I can imagine we'd get. Cost reduction based on your tasks. You could have cost reduction overall because you've improved your requirement quantity and quality. So overall, your system engineering labor on all the verification aspects and the implementation aspects would be reduced. And then you'd have your direct costs potentially with the suppliers. A project then who wants to look at implementing this would compare that to cost of tools and process updates and training and maybe some efficiency delays. And for every project, this could be different. And for some organizations, there might be some investment they'll do across many projects, and maybe they'll do a phased approach for things. So my goal here was to provide measures and then provide some estimates on what some of the benefit costs could be if a project knows their expenses. Now, how do I measure these things then? And there's like 3 different ways I opted to do that for this project. One is you can predict what a task could take just based on the steps within that task. So we call it task labor hours. And for this, I used a series of labor hour ranges. It's hard to peg exactly how long a job would take. You've got variation based on your skill of your engineers, their experience level, perhaps how many things they're dealing with, the complexity of what they're working on. And so what I did was a range of predicted times for certain tasks. And then for projects SC labors, I'll talk about the use of the cost model tool Sysml, and that's essentially an Excel file. And in that Excel file, if we turn a few knobs, such as requirement count, we can get a prediction of SC labor for that project. And you can use it then as a basis of comparison. And then direct costs on supplier changes could actually be a project predicted input based on heritage of a supplier. And I'll go into different ways that could be utilized in this. Okay, so I'm not going to go over these steps in yellow. I'm going to highlight them shortly, but the idea here is you've got a series of steps associated with a set of tasks you do during requirements management. And each of those should take some amount of time. So I went ahead and did a range of times for each of those steps, and then also figured out, well, what is this based on? If this is a document-centric approach, and I'm getting 5 documents on my project, perhaps I have a performance spec, I have an environment spec, I've got a standard for some sort of, structural thing, set of requirements. I've got another standard for some interfaces. If you got these 5 documents and we've got to kind of make sure all of those get worked for a project, those activities may occur 5 times. And yes, there's probably some refinement, and maybe some will take more and some will take less. But the idea here is you're doing it 5 times, and within that range, something will predict what your ultimate task count would be in terms of hours. So that's one of the measures that I use during this, is to figure out for each of the proposed processes, what are the task hours associated. And then this is a snapshot of Sysml, and it's a cost modeling tool. Here's some information about it. It's from Valerity, and it's based on a lot of actuals on space projects. And I think there were many major aerospace companies that contributed some data towards this, because it's not something you'll usually see openly advertised is actual costs on a project. But as part of his PhD dissertation, I think Valerity put the basics together for this cost model, and it's been matured quite frequently since then. But I really like it as a comparative opportunity for me, because one of the functions of inputs it has is number of requirements. And then it has shades of easy, nominal, and difficult. And so if you have an easy requirement, that's a requirement that's absolutely perfectly done, right? It's simple, you can implement it, it's traceable, there's no overlaps at all, and probably not very real world. So nominal tends to be, you know, a good point to aim for. You might have some overlaps, it might be slightly difficult, but you know, it's generally your typical. And then difficult then is poor quality or harder to do. And so the measure of difficult in their paper was ones that had a lot of overlap, were poorly traceable. You couldn't really quite understand it. It wasn't written well. So those difficult requirements indicate quality problems, and number of requirements then deal with your quantity. So I utilize this tool, and out comes then some sort of prediction in SE labor in terms of person months, which can be counted, you know, I guess converted over to hours at some point. But what you're dealing then here is this is the cost of all their work associated with implementing the requirements, verifying them, setting up system level verifications and tests. And so it's more of a high level indication of what you're going to get. When I normalize out and get 0 requirements, it kind of normalizes to a number. And then I'll put some standards in for other project things that I'll just normalize through the whole thing. And I'll just play with the requirement number and difficulty or nominal throughout this assessment. All right, and the last measure I used was change of suppliers, cost due to supplier changes. In particular, there is this sweet spot. If you put a supplier on contract too late, they might not get their product done in time, and your project will likely incur some costs associated with that, whether it's the costs associated with your overall project being late, or trying to speed up work later and compress your test time, or maybe you've got some penalty costs associated with your ultimate customer. There's ultimately some impact for having your supplier deliver late. There's also a cost impact of giving them the work too soon and putting them on contract to requirements when they're not quite stable. And when I say not quite stable, then what does that mean? Well, the idea here is, how many unknowns do you have? TBXs. How many unresolved? How many to be determined? And when you know that's pretty high and you put a supplier under contract, what you're ultimately dealing with later is removing those over time through a series of changes you're going to give them. And in a perfect world, the supplier will only charge you for changes that drive rework or have some significant impact. But in a real world, what they will often do is have some sort of opportunity to deal with the fact that they even have to look at your changes. They have to incorporate the changes into their paperwork. They have to have their team start working to the new things. It's impactful in many other levels as well. So there's just this cost associated with that. The more times you have to put them under changes, the more times you'll ultimately have to pay that cost. So I just made it a linear function for this purpose. And I said, what's that sweet spot where you're not going to incur late penalties, but you're not also going to incur all undue changes. You just wait, mature those requirements, and then ultimately levy them. And so that's what this little optimization Excel file does. It predicts based on your instability ratio, which I show in another slide, is how many TBXs you have compared to your requirements, how much you think you can resolve those TBXs per month, how many times then you'll be levying changes, and what that change cost could be. This is sometimes known by companies. They'll know a certain supplier will be genuinely low in these kind of change costs, and other suppliers may generally skew a little higher. And so if they get a history understanding of what those suppliers will do, they'll know if they want to wait a little bit before applying those requirements. And then you might have some feel for what your delay cost might be per month that you're late with that product. So I've looked at 4 different areas I think I want to optimize. I investigated each a little further to look at their current state and their future proposed state. So I'm going to highlight these here for you and talk about them at a high level. The first one being, looking at more of a data-centric approach to requirements management. And while I have the steps here, I think the other slide really highlights this idea, which is you might have been given a series of individual requirements, or maybe you might have been given a set of needs from different places, and you have a choice on what to do with that. And especially if you're prime, you may break out 10 different requirement documents associated with theme, standards, environments, interfaces, performance functional requirements, quality requirements. Or you may choose to make a database where everything is kind of a holistic set of requirements. And then you could potentially even reuse some common requirements, such as design standards. When you get your lower level requirement, product requirements, then you can just reuse some of these design standards from this database and put them out into their specs. And this is what several of the more modern requirement management tools can do now. So looking at a data-centric approach really is treating all your requirements together, looking for your gaps, assessing your overlaps, understanding the full traceability. Do all of these support ultimately the need of what the system has to do? So the idea here then is, instead of working in more of a document approach and then just checking out your documents, you're establishing a holistic database and looking at all your requirements together and connecting it to other sources of data, such as verification plans, analysis models. Perhaps you have product data having to do with, build of your product, quality inspections of your product, and really connecting all this together. And then when you're dealing with exporting specs, it's just a button and you just export these specs, and you can give it to either soft copy or an actual spec to then the next developer that has to work on it, whether it's in-house or a supplier external to your company. So obviously that's a pretty rich thing on its own, and I'm gonna highlight a little bit about what I learned on that. And I'm gonna go ahead and go on the other process update I was looking at, which is the now use of a tool. And many of us have worked in an industry where a very common tool has been used since the 1990s called DOORS. It's a product from IBM, and it's kind of the premier standard of requirements management tool 10 years ago. When I actually started researching, I find that there's actually a lot of modern tools out there. And now that we have our system engineering tools database getting up and running, you actually can go in and look at all the different tools. But in my dissertation, I did show a series of surveys that were done over the last 10 years. And every time they did a new survey, this independent company did a new survey, DOORS kept falling lower and lower and lower on the list. And why is that? Well, ultimately, it's not a collaborative management tool. It's a database. It can handle a requirement and show relationships, but it's not very easy to use. And it certainly doesn't allow a lot of real-time review in the tool, comments, updates, and essentially user friendliness. It can do a lot of those things, but a lot of people don't want to do it because the tool itself isn't as easy to use as perhaps another tool. So the idea here is use a more modern tool that's easy to use that people will be willing to go in, and you're not taking the time then to have a single tool interface. I feel for some of the system engineers I have known in my career, some of them maybe even on this call, where they recognize a system engineer on a team familiar with a tool like DOORS may be the only person who enters data into that tool. And that becomes their job. Instead of being an actual systems engineer, they're a tool administrator. And I think we want to get out of that business. I think we want to go back to being systems engineers. And so use of a collaborative tool is actually, there's one product called JAMA. They actually conducted a lot of studies that talked about various projects that got improved when more, we'll say, non-systems engineers are in the tool with them, looking at the data, looking at the traces, being able to comment on things during reviews, peer reviews, and being able to update things pretty quickly. It just seemed to add a lot more richness to the review process. Thank you, John. Okay, so this really the idea behind this one. And then this is a snapshot of one of the tools I looked at. I actually got a chance to beta test a tool called JAMA, but I've also tried a tool called IBM DOORS. Next, sorry, don't confuse it with the first DOORS. IBM makes a newer product called Doors Next, and it's comparable to this one. But the idea is, look how user-friendly it is, right? You've kind of got that look and feel of a modern software thing you might do on social media or something on your current job. And so it doesn't, people don't tend to shy away from tools if they're super easy to learn to use. Now, here's this idea of improving your requirement quantity and quality. And the idea here is really highlighted on this slide. So I wrote a paper that I presented at IS 2020. So last July, I presented it virtually that talked about design standards and over-constraining the idea. And that really formulated the study here, which is often when we'll put a supplier on contract, we'll give them a spec, and then we'll give them a bunch of standards. And some of those standards may tell them exactly how to design their product, how to analyze their product, how to test their product. Depending on what industry you are, you might have some sort of regulatory standards. And the idea is, here's a whole bunch of things that are separate in silo. Here you go, supplier. Go give me something that meets those requirements. And then what the supplier has to do then is go through all of that and try and really distill their own requirements and figure out what's applicable, and then say, I think I got it. I think this is what you want me to do out of all of this. And so the idea here is, don't make the supplier do that. They're going to charge you for that work. Instead, let's have the systems team do some work up front to really go through that and figure out what are the applicable requirements. Now, if you have that data-centric approach, they're all there together. Weeding out the applicable requirements might actually be a little easier. But even if you were doing a document-centric approach, don't just take a whole bunch of documents, throw them over the wall to your supplier and expect them to do exactly what you're envisioning they will do. Take some time, go through and consolidate the requirements, figure out what's perfectly applicable for them, get rid of gaps, get rid of overlaps, make sure they're all traceable to your needs, and then give your supplier or your development team the condensed set of requirements. So that's the idea here. And then again, it had a series of steps. And the idea here is not only when I think about the task hours, I would also think about Sysml in this matter. Even if I took the time to reduce something by 10% and get rid of all those difficult requirements and made everything nominal, how much would it improve my estimated system engineering labor for the whole project? Okay, and then the last process update I was proposing was that timing, that sweet spot of when I levy my requirements. Do I mature them till they're perfect and then give them to a supplier in a developing team? Do I give them to them as soon as I can? Or do I try and find a nice spot, look at it, you know, how much do I think till I burn it down to a reasonable level of risk and then levy it? And so that's really what these steps associate with. Then I utilize that Excel file where I try and find that nice sweet spot, that optimal time, where I still might have some change costs incurred, but I'm definitely not going to be waiting so long I have a huge amount of penalty costs. And this is where then I think about what's the instability ratio? It's your number of unknowns and unresolved over your total requirement count. If it's low, you're probably safe to proceed. If it's high, you're probably going to incur a lot of change costs. And then you can kind of predict, if you think about it linearly, what your change count might be if you know how quickly you can resolve those. And typically we'll have some sort of TBX burn down plan that will let us know how quickly we could resolve things based on when we know stuff. So the idea here is just spend some time, put some thought process behind when you actually want to levy your requirements on your suppliers. Don't do it mindlessly. Now, there's a lot of data. There was a lot of measurements I can make and a lot of parameters I was looking at. So the idea here is, how do I do some calculations to kind of put some assessments together to compare these different processes? And I could use this in Excel, but what I liked about the idea of using a system model is it allowed me to look at interactions, allowed me to run some simulations. So I opted to use Sysml. I wanted to learn it anyway, and I was getting familiar with it through work. So if I use Sysml, I need a modeling capability. It can't be static. It actually has to run some numbers and do some simulations. So I was able to go ahead and get a tool through CSU that allowed me to build up a model, run some simulations, and just compare task hours of different things over different parameters like number of changes or amount of documents. and then see how that would compare process one, you know, document centric versus data centric. Now, this is the part where I'm going to highlight quickly, because in the interest of time, there's a lot here. And this is actually something I can post a video on our YouTube channel about, because I gave this I gave an hour on how I did this to our friends at CSU, at Colorado State University. So I can post that. I'm also going to present a little bit of this during IS 2021. But the idea here is I made a Sysml model of the requirements management process. And I made a series of activity diagrams associated with each of these processes. And I call them process 1A and 1B, and 2A and 2B. And I put together some parameters associated with it that are values, variables that I can alter. And when I change those variables and I run a simulation, it can predict how many hours it would take to do that series of steps based on the input of hours per task. And again, I used a range, so I can run a minimum set of numbers and a maximum, and I have an idea of a ballpark this could take. What's really nice is this model could actually be used in slightly different ways too. If I were to think about this overall model, I could put in actuals from a project and start having this help be a predictor tool of certain processes or certain things I do on my program. I can run Monte Carlo simulations and figure out the most probable set of times it might take under parameters. And I didn't necessarily do that with this study, but those are some of the things we were thinking that these type of modeling efforts could eventually move into for maybe others who want to study this. So I'm going to highlight again, there are different ways you can run simulations using Cameo. I was able to use Cameo simulation toolkit, set up a bunch of parameters, run it faster than real time, and have it calculate the results and put them in a folder and report them to a table and report them to a graph. And so for the interest of time, I'm not going to run the demo, but I'll go ahead and post it on the YouTube channel so you can see also the demo video. But essentially, it just runs through and then reports out values and then gives you a chart associated with what each of those would take in terms of hours. And then you can go ahead and export a table, and it reports to a table, to Excel, and then I can go ahead and graph using Excel, and I can look at then the document-centric process task hours versus the data-centric based on number of artifacts or documents. And I'm just going to show you this briefly here, but actually I have a whole bunch of table results that are in later. So these are just more of the simulation parameters. One thing I liked about this is I learned I can connect Excel with Sysml. It was something I learned I could do during this process. So you can actually embed your Excel file, feed it data, have it do some calculations for you, and take out the results and look at it as part of your model input. So that's what I did for my predicted, I would say, optimized time and change costs for my process 4. And then once I got all 4 of those activities done, I did a comprehensive model. So this is a view of my top level V diagram. I was actually able to make a Sysml model of it. And these little forks mean there's another layer of model. So that activity feeds into then a series of activities. So if I were to simulate this, it would go in here, run those activities within that, come back out, and then run the next one in this step. So that will essentially look like this. This is one of those boxes. I was also able to connect the Sysml file for predicted system engineering labor costs. So I built that in here as well. And then I was also able to use both parametric diagrams. If you're not familiar with Sysml, that's just essentially a way to do an equation. And I was able to build in equations directly into the activities. So if I were to consolidate and minimize the requirement by 10%, I essentially had to do the math to figure out what that is. And that is now my requirement count to feed into Sysml. Okay, so these are the results, and then I'm going to open up for questions. But the idea here then is all four of these showed some improvement from some parameter. So whether I was doing data-centric versus document-centric based on task hours, the idea is dealing with a lot of individual documents, even if you're working them concurrently, then you have multiple people working them, was definitely a higher cost in system engineering labor hours than doing more of a data-centric approach. Just because you've got rid of the silos, you're now looking at it holistically. You might still have more than one person on it, but you're still looking at your data holistically. And the idea here is also your data quality will improve, but from this modeling effort, I was primarily looking at the cost perspective. The yellow is, of course, the older paradigm, if you might have seen the pattern already, and the green is the proposed newer one. Now, the collaborative management tool, from a cost perspective, there might be some overlaps here. So the idea here is you might have some cost savings. Yeah. Do I have a question? Oh, okay. You might have some cost savings, but also I'm going to leverage the JAMA study that said when they were actually looking at companies that started implementing a collaborative management tool versus an older tool or more of a Microsoft Word-based tool, they found that just that collaboration effort in the review process saved them $150K per project. Their planning time also reduced. So there's actual evidence out there that this is better. My modeling shows it's probably going to be better, depending on your team. But again, there are some areas where it just might be a wash. And then minimizing and consolidating the requirement results. What's interesting on this is I did have to add, remember that time the supplier does something is not equal to the time your system engineers do something. The supplier costs are typically going to be a little more. They are definitely going to be less familiar with the requirements, and they will typically charge for the amount of work they have to do to study everything. But if you have an in-house team, it's typically could be a wash from a labor perspective if that's being done a little earlier or later. So that's what my numbers showed in the tasks. But what's interesting is if you take the time and minimize and consolidate requirements, you actually may not see the benefit in your task time, but you'll likely see the benefit in terms of your total labor hours if your suppliers had to do it. But you'll see the benefit from Sysml. Spending time, maybe even half a year, if you have a lot of requirements, to really make sure those requirements are consolidated, could save you several months. You know, the prediction on Cosmos may not be 100% accurate for all projects, but the idea of getting rid of your overlaps, improving your quality, improving your quantity, could reap you great predicted savings from the Sysml tool at least. And then evaluating the timing to levy unstable requirements. The opportunity here is if you think you're going to have a lot of change cost, if you have a high cost per change on some suppliers, you want to minimize the number of changes. The benefit of spending that upfront time, maturing them a little bit more, actually yielded a lot of benefits here. And if you didn't have a huge cost per change, it was kind of almost a wash. So going through here, then I ran these models using the known parameters of the different space projects, and I did some quick predicts of what if they had a huge TBX count or huge change costs, ran it for the whole system, looked at basic savings, and kind of predicted some savings you could see on a project like Maven or Curiosity or GOES if you implemented all four of these, right? And Constellation had a huge number of standards and documents they were using. So their costs just look ridiculously high in terms of what I was predicting. But the idea here is it trended along with the success and difficulty I saw earlier, which is just based on the sheer volume of what Constellation had in terms of requirements and standards. We think they definitely would have had a benefit for just a different approach, maybe for requirements management, or maybe a holistic approach versus a stovepipe approach. But the idea here is when you're looking at a project like Curiosity or GOES, maybe spending $100K on a new tool or some new processes or some training might yield the benefit if you're going to see a lot of costs savings associated with the processes you're doing. So that ultimately came, the conclusion is, what do I do with all this? The idea here then is I put together kind of these recommended approaches, and we're going to eventually build this into our guide to needs and requirements on INCOSE as a requirement working group. But the idea here then is go through and put some thought process behind each of these parameters, whether you're going to go document or data centric, whether you're going to use a collaborative requirements management tool, whether you're going to take the time to look at your requirement quantity and quality, or think about how you mature your items before levying them. And then some recommendations based on your project parameters. So that's ultimately where this ended up. And I hope I left you enough time for questions or comments or thoughts. And thank you guys for the nice comments in the chat. I really appreciate it. Yeah, I am done. As I said, the paper is going to be published. The dissertation is going to be published through the university. Through, I guess they use a publishing company. But officially, I'm graduated. So we're all there.
Congratulations.
Thank you.
Yeah,
Wonderful.
congratulations.
Wonderful work.
I appreciate it.
Terrific.
So I'm glad y'all called in. Thank you so much. It was fun to share this with you. I went fast. It was a lot of material to cover, and it's a 300-page paper, so you might choose to skim through it. But I'm happy to take high-level questions. Did a ton of reading and a lot of research on this topic, so it is really interesting to go through all the publications.
Yeah, I think I have an application for this, evaluating a tool that I'm in the process of being trained on at the moment. And it has to do with the quality of requirements and probably the time it takes to do a requirement. And I know our corporate tools committee is going to want to do a trade study. So having something like this to analyze for them, I think will make the study go very quickly. And
you are welcome to use my paper. You can download it anytime. There's also references.
Thank you very much. I was going to ask you that.
No, it's in the documents section of our requirement SharePoint. You just go in the documents and it's uploaded. I have a PDF and a Word version in there, and I have these charts in there. But what I'll tell you is in there is a whole section on tools and a lot of different types of tools, and a company that assessed a lot of tools.
Okay, great.
So benchmarking, if you will, and surveys and kind of a, like I said, doors kind of went down in the premier tool list quite some time ago, and all these other tools filtered up. The tool I chose to deep dive in, JAMA Connect, is pretty highly rated, and I chose to look at it primarily because SpaceX used it, and they've been a kind of a competing company to the companies I've worked at in the past, and they get stuff done. SpaceX goes pretty fast, right? And I'm like, well, maybe they're using a better requirement management tool. Maybe I should look at it, right? And we're actually doing a trade study right now, or a pilot of trying JAMA where I work currently, just to see how it fares compared to using a more traditional tool.
I've heard a lot of good things about JAMA, and our problem is we're not only stuck with doors, we're stuck with doors 9, right? Because we've written a lot of scripts, and moving to doors next gen or either some other collaborative tool is problematic. But we have a person going through trying to compare, a lot of the stuff that you can do with the new tools is what our scripts were for. So it may not be that bad of a jump when we move. But yeah, I would like to move out of doors, even though I like doors and I think it's a very useful tool. It's just, it's not as easy to link it to models if you want to use modeling, and that seems to be the wave of the future. So
this is part of what you're dealing with right here is your expenses. You've got a lot of infrastructure in place. We do too. And we're using doors 9 as well. And so I recognize you have a lot of infrastructure in place. You've got people trained, you've got templates, you've got commonality, and you're talking about circumventing all of that with a new thing. And you have to consider the expenses associated with that, then with the potential benefits. So what I'm doing right now is we have a small program who is, we paid for the licenses for them to use JAMA, and they're using it, and we're comparing their costs, their development time, their turnaround time, and associated effort with a cost on a typical program using doors 9. just to get apples to apples comparison. And I will tell you right now, it took one engineer 3 weeks to do something it would take a couple of engineers 3 months to do in Doors 9. Just right off the bat, we saw those kind of numbers. And so that, while I'm not here to do a commercial for JAMA Connect by any means, I think Doors Next is comparable. The idea is these newer tools have so much built into them already. You don't need all those customized scripts. You don't need to develop all that.
That's what we're thinking and hoping, so that we can, move into a more of a browser centric and be able to, not have a proprietary database to deal with. Those are the types of things where are attractive to most places.
So John asked a question, am I willing to name tools which based on my research best facilitate the characteristics that minimize cost? I think I just gave you 2, but those are 2 that I personally have used. The idea here is there's a ton of tools out there that I haven't used that I'm sorry, there's one on the tip of my tongue and I can't remember. There's so many tools now getting into the SE tools database. Polarian, I think, is the other one I'm thinking of, that has also been reported as another tool like this. Any tool where you're seeing them promote the connection to other things as part of an overall digital engineering effort is a tool to look into. And I will tell you, Sysml can do requirement management. It's not designed to do it. And some people like the idea of doing their requirement management right in their system modeling tool. But I find that you have people approach those tools like Cameo the same way they approach Doors 9. Most folks who are not in them every day tend to avoid using them because they're not super user friendly.
One of the enemies of data-centric, one of the enemies of data-centric is proprietary information of the tool vendors, right? And they haven't really come up with a great standard yet where they'd be able to export their stuff into other tools and back and forth. And that's going to be a tough hurdle to get to, but I think the government may end up pushing to the point where they'll eventually relent, but we'll see.
Well, there's someone from JAMA that I was recently talking to the other day who's interested in perhaps presenting some of the work they're doing in developing some of the natural language processing in their tools. And so he may come on maybe in May to come share some of what they're doing in developing this and overall tool information. I know we've had people from the reuse company in the past do something similar. So the idea here is we might want to, have some of these tool folks show us some of these newer capabilities. I want to make it less about a commercial though, and more about the potential of how these newer modern tools tend to operate and help solve some of our problems.
And I'm on the call, Tami. This is Joseph Federesi. So
perfect.
Yep.
Thank you, Joseph. I didn't want to speak on your behalf if you weren't comfortable with that.
Well, and I'm not going to turn this into an infomercial either, but we're happy to talk about that. And we have some new tools that aren't quite out yet, but coming, and I look forward to talking about those more. And we're hopeful that they will make the hard work of creating and drafting, authoring detailed requirements, complex requirements like this easier. It's still gonna, our tool is designed to help and be an assistant. Still requires expertise for sure, but just trying to make it easier for the people that have these tasks.
I can attest to that because I'm evaluating some software like that, and even though it really is wonderful, there's an awful lot of work up front that goes in. And there's a little bit of, there's a lot of training if you're going to do the administration, but just to use the tools, if you have a good administrator, it should be pretty good. Give you a very high quality requirement and a lot less time. And that really bodes well for like what Tammy's presented today, because it's one of her sections is to get higher quality requirements. So
one thing.
Yeah, go ahead, Lou.
One thing I found when I was working on the needs and requirements lifecycle manual is that when you talk about the quality of a set of requirements, when I really got to thinking about it, I kind of found that process-wise, the analysis and maturation of concepts probably will account for maybe 80% of the quality of the requirement, and how well you craft the sentence, the requirement statement is only maybe 20% of the overall quality. Because I can have the perfectly worded requirement and it could be the wrong thing. It could maybe not be feasible if I haven't delved down into other kind of things. So one of the challenges, it seems to me, is it's so easy to think about requirements, needs and requirements in a silo, almost kind of distinct from the other system engineering processes. But somehow we need to find a way where we really grasp this concurrent nature of all the different processes, so that the modeling is an analysis tool to help us with completeness, consistency, correctness. But then requirements, especially when you're moving down levels, is got to be done concurrently with the architectural definition process. The two processes go hand in hand, and in INCOSE handbook, they're described as separate processes, but they really happen together. And the same with design. You know, one of the characteristics that we have in the guide for writing requirements is that the needs or requirements are feasible, but feasibility is in the world is in the physical world. And so if I'm out also looking at some design implementation of the architectures and assess the maturity of the technologies, I can't say that my requirements are, you know, feasible, so they're not going to have that characteristic. So there's so much concurrent thing going on that this holistic view of system engineering almost says that we need to find a way to work on requirements as part of that holistic system and not try to put requirements into a stovepipe.
Well, what I've tried to do, and what we've done in the guide for writing requirements, is to add all those attributes, and you put risk in there. You know, you can put metrics in there, maturity, and you know, validation and verification attributes. So it ties all of the system engineering, not all of them, but a lot of the system engineering principles together, so that you're not in a silo. And you know, you've heard me say this a lot, Lou. The most important thing to me in a requirement is can I verify it? That's the first thing I look at. Is this easily verifiable? Not necessarily easily done, but you know, do I know when I'm done if it passes or fails easily? That to me is key. And so you know, this makes it easy to tie the verification process into that. And until we started doing that, we were in silos. A lot of our verification people had to write some requirements because they knew they had to be in there because of the testing they normally do, but there was no requirement against it. And it's like such a conflict of interest, in my opinion, that has to come from, you know, the stakeholders. And, you know, then the system engineers giving them a solution and then agreeing to that in the system spec.
So I have to, in the interest of time, just make a note. We're a little bit over. And I actually do have another commitment as well. So I'm thinking we might have another opportunity to talk about this particular topic, because I think it's an interesting one. Maybe we'll make it one of our other meetings.
Sounds good. Well, thank you,
Right.
Tammy.
Tami, thanks. This is Tracy Scott. I did have a quick question,
Yes.
and if we don't get to today, we can think about it. I think it's out of the scope of your paper, but it'd be really interesting to look at not just the number of and complexity of the design, but the life cycle, like requirements for, like, does it have any sort of a factor as well?
Life cycle of the project or requirement life cycle? I saw your question. I didn't understand the context of it.
Yeah, I think of the program, because I know some programs are trying to do complex things in a more accelerated way. And so I want to make sure that we're comparing apples to apples, right? Like, is there another loading factor on what they're trying to do that's influencing, right?
Yeah, and so this was, well, actually the other chart probably showed it better. This was my life cycle model of the requirement management activities over a life cycle. And you've got this monitoring function, and you certainly have your generate requirements. Now, what I'm not showing here is an agile-like process, right? Or I'm not showing necessarily all the iterations we do within this generation of requirements, but I am showing it a bit here. We're updating, and then we're finishing. So the idea here, I think you would probably, if you had a slightly different approach to a life cycle or an escalated one, or you're using something more agile, I think there's some factors you would be putting in some of these things in here to help address it. No, I didn't study
some
that.
of the big design reviews and all, right?
Yeah. And often what I didn't make this your, here's your SRR, here's your CDR and all that. But you generally can see the activities you're familiar with. Like, here's how I'm distributing my requirements. Well, you'll typically do that at SRR. And, along the way, I'm doing my design work and I got a CDR. Well, that wasn't part of the requirement management process, so I didn't play too much with that. But a lot of times you're maturing your requirements and updating them during that effort. And now I'm building it, now I'm testing it. Well, now that's where I'm grabbing verification data and I'm ultimately going to close it out. So I've hit steps along that journey with this model, but certainly not the whole project set of efforts.
And Tracy, that's one thing we're trying to, in the manual, we're trying to make a distinction of the design input requirements that input in the design process, and then the design output specifications, which are going to be given to manufacturers or coders. Sometimes when people use the word requirements generically, they don't make a distinction between the two. And I think it's important too, because if it's a design input requirements, it's really advantageous to make sure we don't put any of the implementation into those, which would allow you to have fewer requirements. And so the cost of developing and managing those requirements and also the verification costs against those requirements will be less because you have limited the design input requirements to just design input requirements. And you haven't mixed apples and oranges.
Thank you, Lou. Thanks, Tami. That helps.
Well, and I also think there's so much more that could be done with a model like this. I think there's, like I said, when we looked at the Sysml version, I'm like, yeah, I could put in actuals. I could put in predicts for some of the other steps that I didn't study. There's certainly refinement of how you do something could affect verification. And so there's a lot, I think, that could be done with this. Certainly I needed to draw boundaries. And so that's where I drew, is really to assess and understand comparisons. But I think somebody who wanted to work on a different research project could pick up what I did and start playing with some of the other measures too.
Yeah, this could go on forever, right?
Yep.
Oh yeah, you got to know when to stop, right? I wanted to eventually finish school. And so, so I did. Thank
Why,
you all
I did it
so
for
much.
half my life.
Well, I appreciate everyone's support. This has been such a fun journey, and the Requirement Working Group is a huge source of information for a lot of what I've been doing. It's one of the things I really enjoyed was a lot of the collaboration with the folks in this group helped really inform some of the research directions I took. And it continues. I mean, I'm going to take a lot of this and feed it back into the guide we're working, right? And so I think it's just this continual learning and growth. So thank you all so much for listening in today. I really appreciate it. Hopefully you have a chance to thumb through some of this if you'd like. But otherwise, we'll see you next month. I'll have another guest speaker or maybe an exchange cafe.